In this video, we'll look at question 51 from the 2016 paper. So in this question, we get given a parabola, x equals 3, y minus 1 squared plus 4, and a straight line x equals 7 in the Cartesian plane, and we are supposed to find the area between these two curves. And by far the most important part of this question will be sketching the curves. So why don't you give it a go yourself? So here they are, and let me just point out some features. So x equals 7 is easy, that's just a vertical line at position x equals 7. And the blue curve is a parabola, but maybe not in the usual orientation as you would know it. It opens to the right. So how do we know the positions of these points here? Well, the x-intercept is when y equals 0. So when y equals 0, we get negative 1 squared is 1 times 3 plus 4 equals 7. That's our intercept here, which is the same point where the red line crosses the x-axis. And then the apex of the parabola will be at y equals 1. You might be familiar with that. If we swap y and x, then you might recognize that this minus 1 and then the whole thing squared just moves the parabola from the center of the coordinates, from the origin to the positive, in this case, y direction by 1. And the value there is 0 plus 4. So that's how we got all these points. And then by symmetry, if this apex is 1 away from the one intercept with the red line, then the other intercept must be at y equals 2. The distance here from 0 to 1 must be the same as 1 to the other intercept. And this green area is the area which we are supposed to find. The most straightforward tool to use is integration. We will integrate in y in this direction, like little stripes like this, so horizontal, from 0 to 2 of the red function minus the blue function. So basically we'll add up all these little bars, which are horizontal in the green shaded region. And after some simplification in the integrand, we get an integral from 0 to 2 of negative 3y squared plus 6y, which integrates to negative y cubed, squared goes cubed, and 6y goes to 3y squared, so from 0 to 2. And when we plug in the upper and the lower bound, the limits of the integral, we get negative 8 plus 12, well, minus 0, so I didn't even write that, and that's negative 4. And in the exam, that was option A, and it's the area between the two curves.